Welcome back to part two of sequential decision problems from framing to modeling to solutions. Part two is the core of the entire talk. This is the one on framing the problem. So, for example, I'm going to illustrate when we take a real problem. Let's imagine we have any of these real problems off to the left, and we want to put it on the computer. There's been this standard process of saying, well, we have to start with a mathematical model. And so in trots somebody who's good with math and can do equations, and he will talk to the users and write down the problem in his math, and then that gets translated to software. So we've been doing this. I've been doing this my entire career. This is widely done. It's considered the standard framework. I actually think it's fairly flawed. And the problem is because we analytics types comes in different flavors. Maybe our specialty is machine learning or Monte Carlo simulation. Maybe I'm an expert in decision trees. Or in a lot of the work that I do, people are experts in math programming and they're trying to find the optimal solution to some deterministic problem. And the challenge here is that we look at a problem through the lens of our training. And this is very subtle, but it's pervasive and it's quite real. And what we do is we see the problem that fits the methods that we've been trained in. I would like to propose a new approach. Now imagine that we're in the upper left-hand corner, we have some business problem, or maybe it's a health problem or a manufacturing problem. Let's just assume it's some generic business problem and we have people, who don't know anything technical, but they're running a business and want to run it better. I would like to propose that we're going to introduce a new step in the upper right-hand corner. Now, this is a group of students at Rutgers. I'm working with the Department of Supply Chain Management there. Now, these are very good students. They're not mathematical. They're not coders, okay? I think that we need students like this to help with a process I call framing. And this is going to be the focus of this segment of the presentation. Now, framing is going to be entirely oriented around asking the right questions, and I actually claim that there's a lot of decision problems where simply asking the right questions will allow us to understand the problem better, and we might be able to go back to the business and help them solve it. But sometimes we're going to need to go to a computer model, and I will also touch on this in part three of the talk, where there will be a little bit of notation, but I'm going to emphasize that the core of this talk is aiming at that upper right-hand corner of people who are asking the right questions in English that helps you understand the problem and lays the foundation for an actual computer model. Now, the computer model can be put into a spreadsheet or a fancy software, but let's now go to the framing. The framing is pretty much summarized by this PowerPoint slide. If you want to run a better supply chain, energy system, health system, anything, you have to make better decisions. I think everybody agrees with that. And the path to improvement starts by answering three questions. What are your performance metrics? What decisions do you have to make and who makes them? And what are your sources of uncertainty that affect how well your decisions perform? Now, when you're solving a problem, I have found that problems tend to come into flavors. One is metric-focused problems where my problem is to maximize the stock price or reduce costs. Maybe I want to minimize overdose deaths or reduce production defects. And then I have the problems where I know the decision. I want to locate a warehouse, order inventory, or route trucks. With the metric-focused problems, I have to go figure out what the decisions are. With decision-focused problems, I have to then design the metrics. And these two end up intermingling. But it's important to realize that both of these are very important and they arise a lot. And you have to, when you're trying to solve a problem, are you aiming at a metric primarily in which you want to make decisions, or are we being given the decisions and we have to say, okay, let's design the metric to help me make the best decision? Okay, let's start off with metrics. Now, in business is very familiar with KPIs, okay? And companies love having long lists of KPIs for each individual. Here's one for CEOs and CFOs and COOs. Now, I enjoy the work of Laura Cesare. She's a very well-known influencer on LinkedIn, over 300,000 followers. She's an expert, a deep thinker about supply chain management. She's not she's not a mathematical person, but she's an analytical thinker. Now, she likes two metrics. She likes operating margins and inventory turns, and she thinks these are the two that really pull together what you have to think about if you're aiming at, say, improving your stock price. My personal style is to build metrics into a pyramid. Now, let's say you're working in a corporate office and your primary focus is the stock price. Okay, fine. Put stock price at the top, and then you'll have another layer. Maybe that's where you do have your operating margin and inventory turns. And then lower down, you have various other metrics. But let's say you're not working in corporate. Maybe you're down in the manufacturing plant, and your top dog is cost. You just want to get the cost down. But of course, you have other metrics that you have to pay attention to. These pyramids are designed to work in any setting. You can put any metric you want at the top. You can be anywhere in the organization, and in larger companies, there's many levels. But it also may be that, hey, I've just been assigned to work on a particular project. And I'm like, okay, fine. For this project, here's the major focus at the top, and then I have various other metrics. So these are adaptable to any situation. Now, categories of metrics. Here's 7 categories. I don't know if this covers everything, but it helps. There's many metrics, but usually they boil down into a certain set of categories. And when you want to evaluate a metric, there's 2 ways to do it. One is average performance. What's your profit per month? What's your cost per unit? What's your drug success rate? So these are your averages, and these are the basic ways that people evaluate performance. But you also have to recognize risk. Now, let me distinguish between a risk event, which is a description in English of an event where somebody, based on human judgment, would say that isn't covered by the average metrics. That isn't captured. If I have a death, if I have a plant shut down, something really severe. And then once you've identified the risk events, then you have to turn it into a risk metric. Now, performance metrics, I like to put them into 3 broad categories. One is objectives to be minimized or maximized. Then there's limits. These are metrics where I want to keep them above or below some number. And then finally, targets are something that I want to achieve. Like a company may want to have a certain financial performance. And you may say, well, isn't a higher financial performance better? And the answer is not necessarily for publicly traded companies, because they create market expectations. They announce that to Wall Street. And if they overperform, then it creates uncertainties and higher expectations and can hurt the stock price in the future. Now, let me talk about this book, The Goal. The Goal, which came out in 1984, has to be perhaps the most popular business book. It's a great book. It's got no mathematics, but it really shows strong analytical thinking. The title of The Goal specifically targets metrics. And what it does is it points a finger at when you're inside a manufacturing plant and you've got various metrics, like I want to maximize the productivity of this very expensive piece of equipment. Well, if you do that to the exclusion of everything else, the goal brings out how that can hurt the overall performance of the factory. So identifying what are the right metrics is the focus of the goal. Okay, decisions, my favorite topic. All right, so I went back 2,500 years to Aristotle and picked out, these are 8 of arguably the greatest names in decisions, from Aristotle in about 2,400 3 or 400 BCE, all the way up to Daniel Kahneman, a professor at Princeton, my generation, one of the great thinkers about how humans make decisions. We've got George Danzig and Richard Bellman, and that invented linear programming and dynamic programming. Howard Rafa invented decision trees. I couldn't find any evidence of any of these people actually defining what a decision is. Now, you can go into these technical books, deterministic optimization. Everybody speaks the language of X. X is the decision. On the right-hand side, in stochastic optimization, you have all this uncertainty, very complicated math, but the decisions always come in 3 flavors. It's either X or action A or control U. In other words, it's always a variable name. They don't actually say in English, but what is a decision? Okay, so let me start with the observation. A decision is a form of information. So let me identify 3 flavors of information. There's what we know or believe at a point in time. There's new information that we create or control. Okay, so this is where I'm changing the system by creating information, which is really making a decision. And then finally, new information that comes to the system from outside that I don't control. Now, a formal definition of a decision is that category 2. So let me offer that my definition, an endogenously controllable information class, basically something we control or a choice among a set of actions. This is where we have to make a choice. Now, the word decision comes in many flavors. You can't go into a company or operation, talk to people and say, what decisions do you make? My experience with that, because I have tried it and I get blank stares. It's just somehow people make decisions, but then if you ask them, what decisions do you make? They can't answer the question. Some of this has to do with the fact that the word decision comes in many flavors in English. Some of it comes from the fact that people make decisions and they don't even realize that they're making it. And that's a topic for another conversation. Now, I've identified 6 types of decisions. Type 1, managing physical and financial resources. This is a huge problem class. People in operations research live in this. This is where communities of math programming tend to focus all of their efforts. Class 2, I'm currently calling discrete decisions. Let's say I have to decide whether or not to purchase a company or launch a new product into a new market, or maybe I have to decide to send a drug out for clinical trials. So these are discrete decisions. Often, they're usually fairly complex, where a lot of things are happening. Type 3 is where I'm acquiring information by running an experiment or observing something. Type 4 is where I'm sharing information, so marketing would do advertising. There's information messaging, which is what to say. And then there's the channels and timing, which is where and when to say it. Type 5, that's a type that is often overlooked. It's choosing a function. So a function can be a performance metric, an objective function, but it can also be how to forecast demand, or it can be what's a model of how information is shared or the spread of a disease. And then type 6 is much more familiar in math programming, tuning parameters. And so functions often have parameters, but tuning the parameters is a decision, but I'm going to put it as its own type. Now, there's different time frames, real-time, tactical, and strategic planning. And also, there's who makes decisions, the C-suite, managers, suppliers, customers, competitors, you. And so we have to think about who does actually make the decision. This takes into the realm of multi-agent. Now, this is one of my very favorite slides. Years ago, I was invited to a workshop at Amazon, and after the workshop, they took us out to a fulfillment center. And as I was walking around, I was making mental notes of decisions. Now, there's an entire class of design decisions that were made when the fulfillment center was designed. And then there's a host of operational decisions. And these operational decisions can come in an operational setting of ordering inventory. It could be in a hospital, in a biologic lab where I'm trying to make drugs, or maybe out in a forest where I'm doing fertilizing and pruning and culling. Whatever the setting, the decisions are not sitting there on a list. You have to identify them. And I like to have my little red book. This is a blank book where people can write notes. And to emphasize the point that we have to recognize where the decisions are. And I think that this is a teachable skill, but it is a skill, and it's not that easy. People often cannot recognize decisions. I love this set of commercials from the 1970s under the category of I could have had a V8. And what they did was the marketing people, and this is just sheer genius, they realized that so they came up with this new drink, a V8 vegetable juice, and they would realize that people would be out there, say, drinking a soda, just automatically not thinking about it and not realizing they could have had a V8. So they would feature actors putting their hand to their head and saying, they're drinking a soda, and then realizing, I could have had a V8. In other words, that soda was a choice. It was a decision, and they could have made the decision differently. Now, what do decisions do? There's physical decisions that move physical stuff around. These tend to be the most obvious. There's financial decisions of moving money and assets around, and informational decisions where I'm moving information around, sharing information, purchasing information, that sort of thing. Now, how do you know which decisions to focus on? And I have this concept of interaction matrices where along the columns from left to right, list your metrics just using judgment from most important to least important. No analysis here. This is just human judgment from somebody who's familiar with the situation. And the rows are all decisions. Now, initially, just list the decisions. In this spreadsheet, which you can download from the link down there, what you do is you enter H, if that decision has a high impact on that metric. M for medium, L for low, N for none, and the spreadsheet will fill in and color it, so H will turn into red. Then the idea is that you look at this, and again, just using judgment, identify the decisions that have the highest impact on the most important metrics. In this way, you can filter down your decisions. Okay, let's go to uncertainties. Now, in the business world, uncertainty, like in the supply chain world, they love to talk about risk and resilience and all the forms of uncertainty. Basically, uncertainty is always translates back to risk because this is what people are worried about and think about. But most of these books are really just have examples of risk. Now, my contribution to this is I have 12 classes of uncertainty that have nothing to do with any problem domain. These have to do with different aspects of a model, so they can apply to any problem class. And it's your job to take the 12 classes and then put them in the context of a problem. So in supply chain management, here's my 12 classes of uncertainty on the left, and for each one, you can have one, you may have none, you may have one, you may have several in each of the 12 classes. Okay, now this is a supply chain examples. Here's one for managing the power grid. Again, I only put one each one. For these complicated problems, you are going to have all 12 classes, but you could have a simpler problem like playing chess where there's only one type class of uncertainty, which is the behavior of opponent. Here's a public health example. Again, all these examples and the 12 classes of uncertainty, they're designed to prompt you, to have you thinking about different ways uncertainty may arrive. Now, once again, you may end up with a very long list of uncertainties and you're throwing your hands up and saying, well, do I have to deal with all of these? Once again, turn to your matrix, fill in the interaction matrix, again, from the most important metric to least important left to right, put in all the sources of uncertainty, identify whether it's a high, medium, low impact of each source of uncertainty on each metrics, and then eyeball that and say, okay, here are the sources of uncertainty that I'm going to focus on. And the point here is it's okay to ignore a source of uncertainty, but make it an explicit choice. Don't do it just because you ignored it. Finally, let me do a quick illustration with an inventory problem. So here's a complicated inventory problem. I have a big warehouse in Atlanta, and I'm getting inventory from the Far East, and it takes months to arrive. Now, in the process, a hurricane may pop up and delay things. I have other decisions, like whether I can air freight something. So this is a fairly complicated problem. Now, the books on this is my supply chain shelf, and these are my favorite books. So these are all books I like, and I've sorted them from the most theoretical to the left to books that have no math whatsoever. Now, the heavy theory books, I view these as primarily entertainment for PhDs. Inventory problems and supply chain problems, if you take streamlined versions, are a great source of math exercises. Now, the books in the middle are the books actually used in business schools and industrial engineering. I roughly view these as watered down models so that you can teach it to students. And when you have decisions and uncertainty, like any inventory problem, I find they tend to be just oversimplified, and you're not even giving the student the foundation. The books I like the most are the ones off to the right. Now, these are books with no math, but they're written with analytical thinking. So, for example, the book The Goal is there, not a math equation in there anywhere, very much analytical thinking. Right next to it, brand new book by Johannes Vermeerl, CEO of Locad. Again, not a single equation anywhere, but this is very much for analytical thinkers. He's got a chapter called Epistemology, another chapter just on decisions. There's Laura Cesaire's book. I love these books. And by the way, there's no simplification just because the math gets too complicated. So here's a typical inventory problem out of one of these books. And it's very simplified and has 4 decisions: when to order, how much, who to order from. The problem is real inventory problems are complicated and they're messy. So I put together my list of decisions. And again, this is, if you look at the URL down at the bottom, you can access this spreadsheet. And I've got decisions made at different time scales. There's about 20 decisions. And once again, are you going to deal with all of these decisions? Now, they're all relevant for an inventory problem with long lead times. But that doesn't mean you have to make all of these decisions. Once again, we're going to turn to our interaction matrix and use these to identify the most important decisions. Also, I would like to announce I've got a brand new book out on framing, and this book has no math. It's written in the style that this talk has been. It's available on Amazon Kindle for $5, which is about as low as I could do it because they won't allow me to give it away for free. And so I think this is a nice resource that I recommend. Thank you for attending the talk. Hope I will see you for part 3.